On July 11, 1979, NASA killed the best space station they ever built. Pieces of it rained down across the Australian outback for over 1,000 kilometers. The town of Esperance famously fined the United States $400 for littering. And the strangest part of this story isn't that they destroyed it. The strangest part is that 47 years later, we still haven't built anything like it. Until right now. Because SpaceX just figured out how to recreate that same lost space station, except 10 times bigger, launched in a single afternoon, and built by robots that will never come home. This is the space station we already knew how to build, and the reason we forgot. Here's what most people don't know. Every space station you've ever heard of, Mir, the ISS, China's Tiangong, has the same problem. They're tiny. The International Space Station looks massive in photos because the solar arrays span the size of a football field. But the actual space inside, the part where humans can move around and live, is just 388 cubic meters. That's smaller than a 3-bedroom apartment. 6 astronauts share it for 6 months at a stretch. And it gets worse. Most of that volume isn't open space. It's stuffed wall to wall with equipment racks, cables, storage bags, science experiments. Astronauts describe living up there as spending half a year inside a moving van that someone else has packed for you. Now, in 2030, that moving van gets destroyed. NASA is going to deorbit the ISS, fire its thrusters one last time, and send 450 tons of hardware screaming into the Pacific Ocean. End of an era. End of 30 years of continuous American presence in space. The race to replace it is already on, and the contenders are everywhere. Vast Space just raised $500 million for a station called Haven 2. Axiom is building modules that launch in 2027. Voyager Technologies and Airbus signed a deal with SpaceX to launch Starlab. Jeff Bezos is funding Orbital Reef. Every single one of them is following the same playbook. Build small modules, launch them separately, bolt them together in orbit. The exact same approach that built the ISS. The exact same approach that gave us cramped tunnels, equipment-stuffed walls, and astronauts going slowly insane inside a glorified storage closet. But there's one company not following that playbook. And to understand what they're doing, we need to go back to 1973, to the space station NASA built, used, and then watched fall out of the sky. The Apollo program ended in 1972. And NASA was left with 3 unused Saturn V rockets, the most powerful machines ever built by human hands. The original plan was to send them to the moon. That plan got canceled, so engineers asked a strange question. What if we don't waste them? What if we take the upper stage of one, the part designed to hold liquid hydrogen, and turn it into a place where people can live? That's how Skylab was born. They gutted the fuel tank, installed floors, added windows, mounted scientific equipment, and on May 14, 1973, they launched the largest space station ever built into orbit on a single rocket. Skylab had 361 cubic meters of habitable volume. That's almost as much as the entire ISS, but inside one continuous open space, not chopped up across a dozen modules. Astronauts on board could literally cartwheel from one end to the other. They had a dining table where the crew faced each other for meals, a deliberate psychological choice to maintain normalcy. They had 3 private bedrooms, a working shower, windows large enough to take in the entire Earth. 3 crews lived on Skylab between 1973 and 1974. They reported the highest morale and best mental health of any long-duration mission in spaceflight history. NASA's own debriefs concluded that crew well-being was directly tied to one factor: room to breathe. and then they let it fall out of the sky. The reason was technical, not philosophical. Skylab's orbit was decaying faster than expected, and the space shuttle, which was supposed to boost it back up, wasn't ready in time. So, in 1979, gravity won. Skylab burned up over the Indian Ocean and Western Australia, and an entire generation of space station design knowledge was effectively scrapped with it. Every station built after Skylab went the other direction, smaller, more cramped, more modular. We have spent 50 years getting worse at this on purpose. Until somebody at SpaceX did the math and realized we already have a Saturn V upper stage problem. Except this time, it's bigger. The SpaceX Starship version 3 is currently sitting on a launch pad in Texas, scheduled for Flight 12 in early 2026. It is 9 meters wide and over 50 meters tall. It can carry 100 metric tons to low Earth orbit in reusable mode, 200 tons if you don't bring it back. It is the most powerful rocket ever built, and it is fundamentally a giant stainless steel tube. Now here's the thought experiment. If Skylab was a converted Saturn V upper stage, what happens when you convert a Starship? The answer is staggering. A single Starship in orbit gives you somewhere between 1,000 and 1,500 cubic meters of pressurized internal volume. 3 to 4 times the entire ISS. In one launch. Of one rocket, built by one company. You don't need 27 launches like the ISS required. You don't need a robot arm. You don't need 161 spacewalks to assemble it. You launch it, it's done. Except, and this is where it stops being easy, a Starship arriving in orbit isn't a space station. It's a rocket that just used most of its fuel. Inside, you've got methane tanks, oxygen tanks, engine plumbing, cryogenic insulation, and structural ribs designed to survive 8 Gs of acceleration during launch. You can't just open the door and move in. Somebody has to gut the entire interior. In space, in vacuum, in microgravity. And no human astronaut can do that. Spacewalks are measured in single-digit hours, not the thousands of hours this conversion would require. The math doesn't work. So who builds it? This is where SpaceX's plan stops sounding like spaceflight and starts sounding like science fiction. Tesla's Optimus is a humanoid robot designed to do anything a human can do. It walks, climbs, manipulates tools, learns from demonstration. Elon Musk has spent 3 years and billions of dollars building it. And here's the strangest thing about Optimus in space. It doesn't need oxygen, food, water, or a return trip. It doesn't get bored. It doesn't get sick. It doesn't get psychologically affected by isolation. The plan, according to multiple SpaceX sources and concept presentations, is to load up to 100 Optimus units onto the first Starship. They cut hatches, they strip out fuel lines, they install floor panels, they wire electrical systems, they weld pressure seals, and when they're done, they don't come home. They stay on board as the permanent maintenance crew. Think about what that means. Every space station ever built has had a problem with maintenance. Astronauts spend up to 80% of their time on the ISS just keeping it running. Fixing toilets, swapping filters, repairing equipment. Now imagine a station where 100 robots handle every routine task while the human crew does nothing but science, exploration, and looking out the window. The exterior gets modified too. The wing flaps come off. You don't need them when you're not flying through atmosphere anymore. The heat shield tiles come off. A second Starship arrives, carrying a massive deployable solar array, larger than anything currently in orbit. The bottom engine bay gets cut open and replaced with a docking port for visiting spacecraft. And when it's all done, you're not looking at a converted rocket anymore. You're looking at a 50-meter tower of livable space orbiting Earth at 28,000 kilometers per hour, ready for its first crew. So what's it actually like to live up there? You arrive through a docking port at the bottom. A Crew Dragon ride from Florida, 8 hours of orbital chase. The hatch opens, and the first thing that hits you is the silence. No engine roar, no radio chatter, just the hum of the life support fans, and the strange weightless sensation of having just enough gravity to know which way is down, and not enough to actually fall. The lower 3 decks are the machine rooms. Power systems, air recycling, water reclamation. This is where every drop of moisture you produce, sweat, breath, urine, gets captured, filtered, and turned back into drinking water. The first time you take a sip up here, your brain knows where it came from. By the second week, you stop noticing. The water tanks line the walls of one entire deck. That's not for storage. That's your radiation shelter. Water is one of the densest known shields against high-energy particles, and when the sun fires off a coronal mass ejection, which happens several times a year, that's where the crew goes. You spend a day or two surrounded by 500,000 liters of liquid armor, waiting for the storm to pass. Move up another level, and you reach the gym. Now, if you've never thought about exercise in space, here's what you need to know. It's not optional. In zero gravity, your muscles begin atrophying within 72 hours. Your bones lose roughly 1% of their density per month. After 6 months on the ISS, astronauts return to Earth so weakened that they have to be carried out of the capsule. Without 2 hours of resistance training every single day, the human body in space simply falls apart. So the gym isn't a luxury. It's life support. Above the gym is where things start to feel less like a spaceship and more like a place. You enter the crew quarters, 20 private cabins, each with a bed, a personal terminal, and a small window. For the first time in space station history, an astronaut can close a door behind them and be alone. NASA's psychological research is unambiguous on this point. Privacy and personal space are the strongest predictors of mental health on long-duration missions. The lack of them on the ISS is one of the main reasons crews start showing measurable cognitive decline after the 4-month mark. The next deck is the research laboratory, and this is where the money lives. Microgravity manufacturing is already a multi-billion-dollar industry on the ISS. Pharmaceutical companies pay millions for protein crystallization experiments that can only be done in zero gravity. Bone tissue grows differently. Stem cells behave differently. There are entire categories of medicine that simply cannot be developed at the bottom of Earth's gravity well. With Starship-class lab volume, every major pharma company on Earth is looking up. Above that is the kitchen and dining area. Hydroponic gardens line the walls, fresh tomatoes, lettuce, peppers, grown in zero gravity. The dining table sits in the middle, and the crew eats facing each other. That detail isn't accidental. It's a direct callback to Skylab, where designers in 1973 figured out something most modern stations forgot: that humans need ritual. They need to look at each other across a meal. It's how you stay sane. Then comes the recreation deck. Open volume, wraparound netting, magnetic chess sets, virtual reality rigs, and yes, zero-G basketball. The first dunks in human history happen here, and the footage breaks the internet. And finally, the very top of the station, inside what used to be the nose cone of a rocket. The hull here has been replaced with curved glass paneling. the observation lounge. 360 degrees of view in every direction. Earth below, moon and stars above. Sun rising and setting every 90 minutes as you orbit. 16 sunrises a day. Astronauts who have spent time at the cupola of the ISS describe it as the single most spiritually transformative experience available to a human being. The Starship lounge is that, multiplied by 10. Now here's the part most coverage misses. This isn't really about a space station. It's about a template. If you can convert one Starship into a station in low Earth orbit, you can convert another into a station in lunar orbit, and another into a station in Martian orbit, and another into a permanent base on the surface of Mars itself, with the crew living inside the same converted hull they flew therein. The Starship station is the prototype for every single deep space habitat humanity is going to need over the next 50 years. It's also the answer to a problem nobody has solved yet. The Mars trip is 7 months one way. 7 months in a tin can the size of an RV will break human beings. Psychologically, physically, neurologically. Recent NASA research confirms that astronauts on long-duration missions show measurable brain changes. Ventricular expansion, cortical fluid shifts, cognitive performance decline. Every one of these problems gets worse the smaller the habitat. A Starship-class vessel is the first vehicle big enough that a human crew might actually arrive at Mars sane. Whatever gets proven in low Earth orbit becomes the literal lifeboat for the next chapter of our species. And it gets stranger, because the same economics that make this station possible, Starship's massive payload, falling launch costs, robotic construction, also make it commercially viable in a way no station has ever been. Vast Space and Axiom are openly selling seats. A week on board could fall to the price of a luxury cruise within a decade. By 2035, the most exclusive resort on the planet may not be on the planet at all. NASA crashed Skylab in 1979 because they had no rocket big enough to save it. They lost an entire architecture of space station design that worked better than anything we've built since. For 47 years, we forgot what we were capable of. Starship is the rocket we didn't have in 1979. And the people building it have been studying Skylab very carefully. The first orbital construction Starship could launch by the end of this decade. The first crew arrives shortly after. And if it works, if the robots build it, if the systems hold, if the economics make sense, then Skylab wasn't an ending. It was a 50-year intermission. We're about to remember what space stations were supposed to be. If you want to see what comes next, how SpaceX takes this same playbook and builds a city on Mars, make sure to subscribe and turn on notifications so you don't miss our next video.